Yes, my greetings. My name is Rishi Bhargava and I train students for CSAT. So today I'm going to discuss some of the divisibility rules, right? So I understand that, for past 3-4 years, they have started putting a lot of questions on divisibility. And many of, students tell me that rules are not available. So today I'm going to showcase that rules are available and how to, crack CSAT questions with it. So first of all, for example, rule of three, all of you, what is divisibility rule of three? All of you know, isn't it? Divisibility rule of three, generally, everyone remembers that sum of the digits of a number is exactly divisible by 3. For example, I say, is 2793 exactly divisible by 3? So what exactly was taught to us was 2 plus 7 is 9, 9 plus 9 is 18, 18 plus 3 is 21. Since 21 is a multiple of 3, 2793 is exactly divisible by 3. I hope everyone knows this, and if you don't know it, kindly write it. So my logic to this is that 21, make a single digit, 2 plus 1 is 3. So kindly make a single digit. So once you make a single digit, if that single digit is exactly divisible by 3, the number is exactly divisible by 3. So this is something we actually know, isn't it? For example, I say what would be the remainder when 27932 is divided by 3? The beauty of this rule is that it gives you remainders as well. For example, over here, I would get my sum to be 23. See, I have added only 2, so I have appended 2 to this number. So definitely sum would be 23. 2 plus 3 is 5. 5, when divided by 3, your remainder is 2. Right? So it is working two ways. It's giving whether the number is exactly divisible by 3 or not. Right? If it is not divisible by 3, what would be the remainder? So all of you agree, many of you know this rule, isn't it? But now take a twist. Now let's see. Please check this out, right? I say, what would be the remainder when this number n, which is 2197 328877 32178 56321156 69 738156321148. What is the remainder when this number is divided by 3? Now, people know that you know this rule of adding a number, isn't it? So I ask you to add this number. 99% of people would leave it, isn't it? 99% of people would leave it, because how would you add 2 plus 1 plus 9 plus 7 plus 3 plus 2 plus 8 plus 8 plus 7 plus 7 plus 9 plus 3 plus 2 plus 1 plus 7 plus 8? No, not possible. I don't agree, right? So now let's change this rule, guys. Whatsoever you have been doing, whatsoever you have been knowing, there is a twist to it. So please just check it out. Rather than adding numbers, now please understand this thing, right? Ignore multiples of 3. Listen to me. 2 plus 7 is 9. Ignore. 9 is a multiple of 3. Ignore. 3 is a multiple of 3. Ignore. If you ignore the full number, nothing is left. The number is exactly divisible by 3. So 2793 is exactly divisible by 3 because we were able to ignore all multiples of 3. Check this out. 2 plus 7, 9. Multiple of 3, ignore. 9 is a multiple of 3, ignore. 3 is a multiple of 3, ignore. What is left is 2. So when 27932 is divided by 3, remainder is 2. So I have changed the rule. From today onwards, remember the rule is ignore multiples of 3. So see this bigger number. See this bigger number, guys. See this. 2 plus 1 is 3. Multiple of 3, ignore. 9 is a multiple of 3, ignore. 7 plus 2 is 9. Multiple of 3, ignore. 3 is a multiple of 3, ignore. 8 plus 7, multiple of 3, ignore. 8 plus 7, 15, multiple of 3, ignore. 9, ignore. 3, ignore. 2 plus 1, ignore. 7 plus 8, ignore. Right? 6, ignore. 3, ignore. 2 plus 1, ignore. 5 plus 1, ignore. 6, ignore. 9, ignore. Right? So you realize 5 plus 7, ignore. 3 again, ignore. 8 plus 1 is 9, ignore. Right? 6, ignore. 3, ignore. and 2 plus 1 ignore, 5 plus 4 ignore, remainder is 8. So 8 when divided by 3, your remainder would actually be 2. So n when divided by 3, remainder would be 2. So it's just a classy thing, right? From today onwards, I'm changing the rule, right? I don't know whether you have heard about this or not. So remainder for 3, divisibility rule for 3, ignores multiple of 3. That's it. All right. Then comes a very big issue. I don't know, but today I am going to, declassify this thing. A lot of time I've heard a lot of teacher would say there is no divisibility rule for 7. There is no divisibility rule for 7, which I think is wrong. So I say rule of 7. So ladies and gentlemen, please, UPSC aspirant or all any kind of aspirant, please rule of 7. So most of the time teachers also tell me, and this time in your 2020 UPSC exam, there was a question, right? So what is divisibility rule of 7, right? So there are all rubbish rules of truncation and all, a lot of thing has been written about it. So today I give you a beautiful rule, right? Remember the series 1, minus 2, minus 3, minus 1, 2 and 3. Just put it in your mind. Just put it in your mind. All right. So my question to you is, sir, you would definitely ask, sir, okay, we remember. All right. What is the use? Now please pay attention, right? I say is 4949 a multiple of 7? You know it is. Absolutely, you know it is, right? But just for an example, I'm saying it. So what do? You write 4949 starting from the left hand side below these numbers. All right, below these numbers. So what is 4 ones are 4? Multiply these, right? What is 9 into minus 2 minus of 18? What is 4 into minus 3 minus of 12? And what is 9 into minus 1 minus of 9? So whenever you add this whole thing, right, you realize you get minus of 35. So when the composition of these products, addition of these products give you a multiple of 7. Now minus of 35, a multiple of 7. Multiple of 7. So wherever in the answer you get a multiple of 7, the number is exactly divisible by 7, right? So 4949 is exactly divisible by 7. Now listen to me, right? I say is 1001 exactly divisible by 7. So just check out what would be the product giving you. 1 ones are 1 and these would be 0, 0 and minus 1, which gives you 0. So whenever you get a multiple of 7, you actually have a number exactly divisible by 7. So 1001, is this divisible by 7? Yes, it is, because 0 is a multiple of every number. So one more information, right? So whenever you get a multiple of 7 or 0, the number is exactly divisible by 7. Right? Now, a lot of students, they feel, yes, this is something we have been missing, right? 1, minus 2, minus 3, minus 1, 2, 3. But I think one question would crop into your mind, that is, sir, this is just 6 numbers. If they give you a 8-digit number or a 10-digit number, what would you do? What would you do? Guys, I understand, right? I understand. It should then be 1, minus 2, minus 3, minus 1, 2, 3, and repeat the series, right? Again, 1, minus 2, minus 3, minus 1, 2, 3, and repeat it as many times as you want it. Clear? As many times as you want it. So now it becomes so comfortable. I say, if I ask you a question, I say, is 1, 0, 0, 0, 0, 0, 0, 0, 0, 1. Is this divisible by 7? Or what would be the remainder when this number is divided by 7? So just check it out. 1 and remaining these are zeros. And this is minus 1. So end product is 0. This number is exactly divisible by 7. See, I have saved you with a lot of pain. Do you understand what would be the pain otherwise? I think you do these things, right? Otherwise, most of you would be doing this. divided by 7, remainder 3, and then 0 comes down 28, and 2, and then 0 comes out, and you understand, you are consuming space. There is only 2 rough pages. This is what they want you to do. Consume, right? So for example, this year, 2021, you realize that UPSC gave a question. Now please check this out. It's not my question. It's nothing. I say that I have created it. See this, right? They said like the question was what 3, 7, 9, 8, 1, 2, 5, P 3, 6, 9. This is a number given to you, and the question was this number n is exactly divisible by 7. This number n is exactly divisible by 7. So what could be the value of P? And options given to you were value of P is 1, 6, 7, and 9. So if you don't know the rule, definitely you will put the value divide by 7, put the value divide by 7, isn't it? But you being my student, our students, just know the rule. So this is it, 1, minus 2, minus 3, minus 1, 2, 3, 1, minus 2, minus 3, minus 1, 2, isn't it? And you don't need to write the full thing, right? Wherever it stops, right? So let's see. So 3 ones are 3, and this is minus of 14, and this is minus of 27, this is minus of 8, and this is plus 2, and this is plus 6, plus 5, minus 2p, minus 9, minus 6, plus 18. This is what you get, right? And if you add this thing, see, if you want to add it, manually add it, see this. This is minus of 22, and minus 27 is minus 49, and this is 3, isn't it? And then you just check out, this comes out to be 11, 13, and minus 2p, and this is minus 15 plus 3. Now this number is exactly divisible by 7. So why do you want to bother about minus 49? Ignore it, because minus 49 is a multiple of 7. All right. So what are you left with? You realize you are just left with, see this, 3 plus 3 is 6, right? 19 minus 2p. And 19, again 19, when divided by 7, comes out to be what? Right? Just check out 5 minus 2p. Now 5 minus 2p has to be a multiple of 7. So just check out. 5 minus 2p. See the level of questions they are giving you. 5 minus 2p, a multiple of 7. If I put 1 over here, this gives you 5 minus 2, which is 3, not a multiple of 7. If I put 6 over here, it is 5 minus 12, which is minus of 7, multiple of 7. This is your correct answer. Tell me, tell me what to do. You have to know these concepts, guys. Other than that, nothing can happen, right? And believe me, if you find this rule anywhere other than Shubhranjan classes, let me know, right? You won't find it anywhere, right? So next, let's see. Similarly, see, divisibility rule of 11. Now, most of the time we have been doing it sum of even numbers, even places, isn't it? Sum of even places minus sum of odd places is either equal to 0 or multiple of 11. But at the end I realize, have you ever asked why? I want to ask you why. Why would you take this as a rule, sum of even places minus sum of odd places? For example, I say is 783 a multiple of 11. So this is absolutely what you used to do. 7 plus 3 plus 8. This is sum of odd places, first and third and fifth, isn't it? Sum of odd places. So you say sum of odd places comes out to be 18. Then, sum of even places. So here sum of even places comes out to be 8 plus 7 plus again 18. So if we say sum of even minus sum of odd comes out to be 0. So 783 is a multiple of 11, agreed. But why? See, the whole point over here is, I sincerely believe knowing a why generally works for you, isn't it? I have that in my mind, that knowing a why generally works for you. Right. So let's see. Why? Because there is a series behind it, right? Like 7 had the series. 7 ka series was 1 minus 2 minus 3 minus 1 2 3. So series for 11 from today onwards is 1 minus 1 1 minus 1 1 minus 1. Take it to infinity. No problem. Write as many as you want. All right. Write as many as you want. For example, again, let me take the same number. 783. 783. Right. So 7 ones are 7, and 8 into minus 1 is minus 8, and 3 into 1 is 3. And then this is minus 7 plus 8 minus 3 comes out to be 0. So if your final product comes out to be a 0 or a multiple of 11, or rather I would say only a multiple of 11, the given number is exactly divisible by 11. Clear? So now you have a reason behind doing something, and I believe, generally this UPSC exam and other competitive exams are actually turning towards a reasoning part. Right. So you have to have a reason behind things. All right. So after this, I say, what would be divisibility rule of 13? Again, most of the teachers would say there is no rule for 13. Divisibility rule of 13. But I'm telling you, there is a rule behind every number. We can create it actually. I've done my MSc in maths, MPhil in maths, MBA marketing, doctorate mathematics. So I can tell you there is a reason behind every rule. So rule of 13. Guys, see this. 1, 4, 3, minus 1, minus 4, minus 3. Remember the series. You know the series, you know the result, right? For example, I say, is number 1, 3, 2, 6 exactly divisible by 13? So you write the number like this, right? Please write the number like this. So just check out. 1 ones are 1, and this is plus 12, and this is plus 6, and minus 6. So you get 13. So if you get, after the series and you multiply and you add, if you get a multiple of 13 or a 0, so over here, if you get a 0 or 13k, the number is exactly divisible by 13. So I don't know why, these rules were not known, right? This is obviously, if you are into core mathematics, you may be knowing it, may not be knowing it, but few things, always keep few things in mind. 7 into 11 into 13 is 1001, really important. One day you may say this number 1001, so factorization of 1001 is 7, 11, 13, right? And all of these numbers, this 7, 11 and 13 have series, so I'm writing those series. For 7 it is 1, minus 2, minus 3, minus 1, 2, 3. And for 11 it is 1, minus 1, 1, minus 1, 1, minus 1. And for 13 it is 1, 4, 3, minus 1, minus 4, minus 3. Now you know the rules, spread happiness about the rules. So this is just a cliche. I mean to say, is this just a highlight of the divisibility rules? Come join the classes. We start divisibility rule from 2 and we go up till 25 as it is required, right? So divisibility rules are important because every year for past 3-4 years, they have been discussing rules. They have been discussing divisibility. I hope you have understood these rules, and I hope that you watch this video with a lot of intent and happiness. My blessings to you. Thank you so much.